Hey everyone, this is Abdul Sami, your AI engineer. Okay, so this is the first video of our series, the LLM series. And in this video, I'm going to tell you basically like how we can build this AI system from scratch. Like this is a transformer architecture. And one thing I just want to going to promise to you at this moment, like after watching this whole series, you are going to build any LLM model from your hand easily. Like you can train it on any data set from the website, and these things you can do it easily on your own system. Okay, and we are not going to build something like a big LLMs, like huge LLMs, like how OpenAI do it. Of course, this is something like we need a very vast amount of GPUs. But I will tell you how we can build a small language model which we can run for this enterprises for specific companies. Okay, so we can run it on our own GPUs as well, which we can afford it. Okay, so that's the one thing we are going to do, and the architecture will be the same. Even if you are going to train it on a big LLMs, the only thing you need a data and a bigger infrastructure. But the base will be the same. Like this whole transformer architecture will be the same for each and everything. That's the one thing you need to understand it here. Okay, so this series is something like we will do something like a theory work, and we will also do something this LLM kind of stuff for using a coding using PyTorch. Okay, but if anybody wants to do something in TensorFlow, so you can tell me. I can make the same thing in TensorFlow as well. No worries at all. But for timing, I'm going to go with the PyTorch along with, of course, all other stuff. Okay, this architecture. No, in this at this time you are feeling like, oh, it's very complex. How we can do it? But after watching this whole series, it will be really easy for you to understand. Even if you are very new to generative AI, so it's easy for you to understand how actually things are working. So in this series, we are not even covering this specific part. Okay, but we are also covering all the perspective how actually things are working, what actually the matrix is what actually the math behind this each and everything. So I will explain you each and everything in very detail. So let's get started. So first of all, let's go to build attention mechanism. So what actually attention is? If you can see this block right now, it's very complex, so I will make it very easy for you here. So whenever how actually the model works, this whole architecture is also a type of neural networks. So one thing you need to understand in terms of AI, the AI model does not even understand how actually we people are talking like in English. Let's suppose if I say, "Hi, how are you? Ali likes pizza." So of course, model does not even understand these words, but model understand the numeric things, the numeric digits. Okay. So one thing we need to do is we need to convert the words into numbers, a random numbers. Let me give you an example here. Model only understands numbers, okay, but this text is in English. We need to convert that text in a number. So this is what we have done it here. We write a text and we convert into in numbers. So it's easy for the model to understand it. Now come to the attention part. How actually attention part will work? Let me give you an example. What actually attention is. Okay, so let me explain you what actually this thing is. There are three types of stuff here. One is key, one is query, second is key, and third is value. So what actually these things are? Query, key, and value. Let me give you example in terms of database. Like I think everyone is familiar with the databases. Like in database, there is a column, and there is a word data in the database. So what actually these things are? Let's suppose you go some hotel and you say, and the hotel manager say, okay, you say your hotel manager, like, can you please tell me my room number? I need to go there. Okay, you book some hotel, let's suppose. And then hotel manager say, can you please tell me like what's your name is? And then you say, yeah, my name is, let's say in my case, my name is Abdul. Okay, and now hotel manager is going to write a query. ABDU. Let's it's not write like ABDU. And then there might be, a randomly 2 to 3 words comes, 2 to 3 people comes, and there is one people name is Abdul. Who say, oh yeah, here's Abdul. Okay. So when writer write a query, so this is same thing exactly the Q means is. Like this is something like query means what actually you need. Okay. Key means when you find something from a database, okay, that's the name Abdul, that's actually the key is. And what's the value? Because you need your room number is your value is here. Okay. Query, what actually you are looking for. Okay, query, like what you write it. Key, what actually thing is it in the database? And value, what actually you got from it. Okay, that's the value, like the room number. So these three things you need to understand when we are working with attention mechanism. And why we need attention mechanism? That's the thing. Come back here. Because we say John loves pizza. Okay, let's suppose if I give that sentence to a model, John loves pizza. So model will say, yeah, John, first model focus on John, then loves, then pizza. But we need to tell our AI model, we need to tell AI model what actually the meaning of loves here. And if I change something like here, pizza loves John. I just change the position of the sentences. The words are the same. I just change what the position. The whole meaning is changed. So the main concept is here. Like now, in this case, model needs to know this sentence is totally different from this sentence. So how actually model knows that thing? But if we randomly select 5, 10, 20 these numbers and make it embedding and put in a model way to a model. But the main problem is if model focus on only one word other than the sentence, model did not capture the context. It's only focused on words. The problem is each word has a different meaning in a specific sentence. So word does not have their own meanings. The meanings depend upon how actually that word is presenting in the sentence. So that's why attention comes in here. The overall concept of attention is like to focus on each words, to focus on each word here, and then tell the model, okay, in here this word had actually representing this meaning in this whole sentence. First of all, we need to do import torch. This is the library we need. Import towers dot nn as nn, and then import sorry torch dot nn dot function as f, and maybe we need and sorry as f, and import numpy as np this thing, and let me run it. And now we are going to implement self no the auto suggestions, self attention, and then dot module. Okay, so AI is going to give me suggestions, but I'm not going to do what he is giving me suggestion. Okay, so basically, as I explained to you, what how actually it will work, as I mentioned to you, first of all, if we open this, we need to do something like this. How query will come, how key will come, as I explained to you here. First of all, whenever, okay, let me explain you here as well. Whenever the word pizza comes, it goes to a query vector first, query matrix first to give me, this is the pizza words come, sorry, and oh come on, why it's happening in that way? And it will become query weights because it's going to query vector. Okay, because I will get a query vector from using here. So how actually I will implement this? Simply I will come here, dev init, okay, self comma embedding dimension I need, okay, and simple. Okay, let me write this in a way. Okay, and self dot. No, okay, let me write. Of course, first we have this query weight. Query weight is equal to nn dot linear embedding dimension comma embedding dimension. And bytes is equal to false because according to the paper, we are not going to add any extra bytes here. And same going for key and values are giving suggestion. Scaling. No. Okay. Query, key, and value. These three vectors we needed because we need to do something like here. We are going to put pizza in the query. So this is will be a forward function where we are giving a position encoding. Position encoding. Okay. I'm going. Okay, and let me turn on. Okay, and then how we get a query? Q is equal to, as I mentioned, self dot q wait position encoding. This is how we get the query. So sometimes AI give you some suggestions in that way. So Okay, and you can see this is how we get Q weight. Same goes for how we get a K. So this is something like self dot K weight. We are going to pass position encoding. Now we have query and K. How we have seen here. Copy this pizza. We are going to pass it to a K, and we call it key and pizza. Okay. And once we get a query and key vector, once we get a query and key vector, that according to the formula, what we need to do, we need to do a matrix multiplication query along with the key of the transpose. Why we need to do a transpose, I will let you know as well. So query matrix multiplication with key dot t. Okay, why we need a key transpose? Just because to perform a matrix multiplication, there might be chance your matrix will be like three dimension, 3 by 3 matrix. If we say 3x3 is equal to, maybe your your embedding dimension is 3 by 2. Okay, so is not possible, like 3 by 2 into 3 by 2. It's not possible if we say query and key dimensions are 3 by 2 and 3 by 2. So it's not possible to do a matrix multiplication. So using a transpose, we will convert it into through x3. So the matrix multiplication is possible. That's why we need to do a transpose here. So here, what I'm going to do, I'm going to get a weight using query matrix multiplication with k dot t divided by np dot square root. And how we can get a square root, like k dot size of -1. So this is like I am getting, I'm getting a dimension, like why we need to do this square root, because when we do the matrix multiplication with query along with the key, it will give me an unscaled similarity response of the matrix. For scale it to get a scale similarity response, we need to do with np dot square root. This is how it's actually defined it here, under the square root dk to get a scale similarity set responses. And then after that, after doing this, then of course we need to apply here a solve function, and then do a matrix multiplication with v. So for applying a solve function, what we need to do, weight is equal to f dot softmax, oh, softmax weight comma dimension is equal to -1, and then output will be, this is our self dot w weight, like we can say self dot w weight a position equivalent, so we can uh, do it here, like because we need a v value, self dot this, and output is equal to where this and return output. This is how it will be done. Simple. Also, you need to put comma. This is how it's done, and how actually we can use it. Simple, self attention is equal to self attention embedded dimension is equal to, let's suppose our dimension is 2 only. Just to tell you, okay. And then I'm going to do position in encoding, because I will tell you how we can do it as well. Okay, so torch dot tensors. Let me make some tensor 1 comma 2 and 1 3 comma 4. But it's not something like integer value. We need to define some uh, random values here. Okay, let's go like this. And then let me call a self attention to get how we get a response. So give me error, but two are given. Oh, sorry. Adding dimension. Then position according self. So, oh, sorry, it's giving me torch. Okay, this is error. Forget to do it. Command the type floor 32. It's automatically gets, we don't need to put this. Now you see we got this response. So this is our final, the attempt how model give me a response. This is our final value. And even like if you want to do a more something like self the attention Okay, like this is how we can get something. Tension dot parameters. So you can see you can get all those parameters in here. Okay, and also you can also get something like transpose maybe. No, no, but weights. How can I get the weights basically to see? Yeah, yeah, sorry, it's q is dot weights. You see how you can get a weight. So this is how you can get the weight, like what my qw is weights. Because as I mentioned to you, like when we are passing a value, there are some query weights, there are key weights and w weights. So this is how these weights are randomly initialized there. Okay, 0.5329, 0.695, and these weights will be changed when we are going to train our models continuously, and these weights are changed, adjusting accordingly, and then we will get a final response. And this is only for the attention mechanism. Of in next videos when we are going to build properly full-fledged system, and then you can see how actually these things are working. Now I hope you understand attention mechanism, how we use it, and how actually we can do in terms of coding. So see you in next video. Bye bye.